The position argument of a geom function describes the positions of the objects produced. Most of the time, this is pretty straightforward and you don't need to do any customization, but there are certain times when it can be helpful, or as I'll show you later, unhelpful, to customize the position argument. We'll first talk about jittering the data. It can be useful to jitter data when you have data values or information that overlap, which makes it more difficult to interpret a plot. In that case, you can jitter the data slightly, which means you slightly move the data so that the values or information are no longer overlapping. Though the graphic won't be quite as accurate as before, the large-scale distribution will be easier to interpret and understand. To illustrate the usefulness of jittering data, we're going to use the Galton dataset from the histdata.r package. This dataset includes variables related to parent and child for 928 different observations. The parent variable is a numeric variable indicating the average height of a child's mother and father in inches. The child variable is also a numeric variable, and it indicates the height of the child in inches. The reason why it's going to be useful to jitter the data for this particular dataset is that the data are rounded to the nearest 0.1 inch. Additional information about this dataset can be accessed by running $histdata: Galton in the console. Because the data are rounded, this is going to lead to overplotting in our graphic, where overplotting means that the values overlap one another. In the code below, we first load the Galton data frame from the histdata package. We then create a ggplot using the Galton data frame, and then create a scatter plot using geom_points, mapping the child variable to the y aesthetic and the parent variable to the x aesthetic. This produces the graphic shown here. We see a pretty regular pattern in this graphic. We can see that the points are equally distanced horizontally and vertically. The overall pattern is that the parent height increases, the child height tends to also increase, though the relationship is rather weak because there's a lot of variability vertically as we move from left to right along the x-axis. The reason that overplotting is an issue in this graphic is that even though there are 928 observations, there are definitely not 928 points shown in this graphic, so it's difficult to say where most of the data lies. So we're going to use the position argument to jitter the data so that we can get a better idea of the overall distribution. That is what is done in this code here. Notice that the only change I've made in comparison with the previous code is that I've specified the position argument in the geom_point function to equal jitter. That takes the individual values and jitters them just a little bit. I wouldn't say there's a lot more to gain from the resulting plot, but because the data are jittered, we can now see the individual points. So there are many more points shown in this graphic, and we can clearly see that the bulk of the data arise in the middle of the plot here. So most of the observations have parents with heights between, say, 67 inches and 70 inches, and most of the children are between 65 inches and 70 inches. And then the number of observations gets fewer and fewer as we move away from the center of the distribution.